Today, we will be going over section 2.3 in your book. We will be talking about conditional statements. A conditional statement is a statement that can be written in if-then form. There are two parts to every conditional statement: the hypothesis, which is everything that comes after the word if, and the conclusion, which is everything that comes after the word then. The hypothesis is usually represented by the letter P. The conclusion is usually represented by the letter Q. In symbol form, we write a conditional statement as P arrow Q, which reads, if P, then Q. Many conditional statements are not written with the words if and then. The easiest way to pick out the hypothesis and the conclusion is to rewrite the statement in if-then form. For example, the statement, points will be deducted from any paper turned in after Wednesday's headline. If the papers are turned in late, then points will be deducted. Therefore, this is the hypothesis, this is the conclusion, and we can rewrite the statement as, if a paper is turned in after Wednesday's deadline, then points will be deducted. Now we're going to talk about truth values of conditionals. This can get kind of confusing, so please make sure you pay close attention and re-listen to this video if you need extra help. When the hypothesis of a conditional is true and the conclusion is true, that makes the statement true. For example, if Tom finishes his homework, then he will clean his room. If we assume that that statement will happen, that if Tom does finish his homework, then he will clean his room, then if the hypothesis is true and the conclusion is true, that is what makes that statement true. If the hypothesis is true but the conclusion is false, that is a counterexample. That makes that statement false. If Tom finishes his homework and then does not clean his room, that example makes this conditional false. The confusion comes when the hypothesis is false. If the hypothesis is false, the statement really is irrelevant. Because the hypothesis didn't happen, it doesn't matter what the conclusion is. That particular example will not make that conditional false. So if Tom does not finish his homework, it doesn't matter whether he cleans his room or not. That example does not make the statement false. Notice this truth table here. A conditional is only false in this truth table when the hypothesis is true but the conclusion is false. Remember, that is a counterexample, and a counterexample makes a statement false. None of these other examples are counterexamples, and therefore the statement is true. Once again, a conditional is false only when the hypothesis is true and the conclusion is false. When the hypothesis is false, we consider the statement irrelevant, which means that it is not false and automatically true. A conditional is always considered true when the hypothesis is false, regardless of what the conclusion says. There are three statements that are related to a conditional statement. All are also conditional statements. When I have my statement, if P, then Q, an example of that could be, if two angles have the same measure, then they are congruent. This is a true statement because there are no counterexamples to that statement. If two angles have the same measure, they are congruent because that's what congruent means. The converse of a conditional statement means that we are going to switch the hypothesis and the conclusion. This becomes if Q, then P. So if I take my original conditional, the converse of that would be if two angles are congruent, then they have the same measure. This is also a true statement. Congruent means to have the same measure, so there are no counterexamples to that statement. The inverse, we keep the original order of the original statement, but we use the negation of the hypothesis and the conclusion. So we do if not P, then not Q. Once again, using the original example, for the inverse, this becomes if two angles do not have the same measure, then they are not congruent. Finally, we have the contrapositive. The contrapositive is a combination of the converse and the inverse. You switch the hypothesis and the conclusion, and you use the negation of each of those. So again, if our original statement is if two angles have the same measure, then they are congruent. The contrapositive becomes if two angles are not congruent, then they do not have the same measure. Now I would like you to pause the video to do the following activity. I want you to come up with your own if-then statement and determine its truth value. You are making up whatever statement you want, it can be mathematical or not, and its truth value. Then, from your statement, I want you to write the converse, inverse, and contrapositive, and write their truth values also. After you finish that activity, I would like you to create a truth table to show two statements, P and Q, a conditional, if P then Q, its converse, if Q then P, inverse, if not P then not Q, and contrapositive, if not Q then not P. And show the truth values in your table for all of those statements, determined by your combination of truth values for P and Q.